so now we're going to be looking at Pascal's triangle. So what I want you to do is first just look at this triangle. This is known as Pascal's triangle. And try and take a guess at what you think the next rows will be. See if you can find the pattern. Go ahead and pause it for a second and find the pattern. And then once you think you found the pattern, go ahead and unpause it. Or if you end up not being able to find the pattern, go ahead and unpause it. So if you're looking, all right, so hopefully maybe you found the pattern. If not, if you're looking at every term here, or all these numbers, first of all, you'll notice that the first one, it always has another, creates a triangle, so it always has an extra number each row. So it's always going to be a 1 at the beginning and the end of each row. So hopefully you saw that part of the pattern. Otherwise, the rest of the pattern, if you look at any number and look at the numbers on directly above on either side, you'll notice that the number below is the two numbers on either side of it added together. So this would end up being a 7, 21, 35, 35, 21, 7. The next row would then be 1, 8, 28, 56, 70, 56, 28, 8, and 1. All right, so that is how you form Pascal's triangle, and you can keep going. You want to make sure you know how to make Pascal's triangle, because that's not something I would give you. I don't expect you to have it memorized, but I expect you to know how to create it. So that's Pascal's triangle, that's what it is. What we can use Pascal's triangle for is it can help us to expand binomials. All right, so prior to this, if you wanted to figure out what x minus 6 to the 5th power is, you would have to take x minus 6 times x minus 6 times x minus 6 times x minus 6 times x minus 6 and start multiplying. All right, Pascal's triangle allows us to have a shortcut. So when you are, it only works with binomials, so I'm going to mention that first. So if you had 3 terms in here, then you have no choice, you have to go the old-fashioned way. But if it's a binomial that you're taking to a power, you can use this little Pascal's triangle shortcut. So here I'm taking this to the 5th power. All right, so what I'm going to do is I'm going to find the 5th row in Pascal's triangle. And what I want you to notice is because we can take something to the 0th power, the top is actually the 0th row. So the first row is this second one here. So when you're looking for the 5th row, it's actually 6 down. One way that you can help tell and remember is if you look at the second number in the row, that'll always tell you which row it is. So this is the 5th row right here. So 1, 5, 10, 10, 5, and 1. So I'm going to start by writing 1, 5, 10, 10, 5, and 1. And notice how I left some space in between them because there's going to be more stuff going in there. The numbers in the row, in each row of Pascal's triangle, will tell you the coefficients of the binomial expansion to that power. Okay, so each one is unique depending on what the binomial is. So we somehow have to tie this x and this negative 6 in there. And so what we do next is starting from the left, working your way to the right, take your first term, which in this case is x, and start with taking it to whatever power you're doing. So in this case, it's x to the 5th. Then it's going to next be x to the 4th, x to the 3rd, x squared, x. Your last one won't have a variable, or you won't put anything on the last one. Next, what you're going to do is do the same thing with the negative 6, starting with the right side. So negative 6 to the 5th power, but that's on the right side. Negative 6 to the 4th, negative 6 to the 3rd, negative 6 squared, negative 6 to the first. And just like we didn't have one for the last term there, going the other direction, we don't have one for the last term. All right, this is basically your this is your expansion, only we have to actually do a little bit of simplifying down. So each of these is each term of our final, or our expansion. So here I have 1 times x to the 5th, which is simply just x to the 5th. Here I have 5 times x to the 4th times negative 6, which gives me negative 30 x to the 4th. Here I have 10 times x to the 3rd times negative 6 squared. Well, negative 6 squared is positive 36, and positive 36 times 10 is 360. So I have plus 360 x to the 3rd. And then I've got 10 times x squared times negative 6 to the 3rd. Negative 6 to the 3rd is negative 216. Times that by 10. You get negative 2,160 x squared. Okay. Next term I have 5x times negative 6 to the 4th. So negative 6 to the 4th is 1,296. Times that by 5. And so then I have plus 6,480x. And then my last term is going to be negative 6 to the 5th, which is going to be minus 7,776. All right, so we can do the same thing with this next one. I'm going to go back this time. I'm going to find the 4th row. The 4th row, so it goes again 0, 1, 2, 3. 4th row is right here, 1, 4, 6, 4, 1. So 1, 4, 6, 4, 1. Start with my first term, x to the 4th, x to the 3rd, x squared, and x. Then start from the other side with my second term, 2 to the 4th, 2 to the 3rd, 2 squared, 2. And then just simplify that down. X to the 4th. Here I have 4 times x to the 3rd times 2. That's 8x to the 3rd. Here I have 6 times x squared times 2 squared. 2 squared is 4 times 6 is 24x squared. 4 times x times 2 to the 3rd. 2 to the 3rd is 8. 8 times 4 is 32x. And then lastly, I have 2 to the 4th, which is 16. All right, go ahead and try the next two on your own. And then you can go ahead and unpause and see what you got. So for the next one, again, you can pause it now and then play and compare. So the next one we're taking to the 2nd power. That's this row. 1, 2, 1. X squared, x. 1 squared, 1 gives you x squared plus 2x plus 1. And then this next one, get 1, 3, 3, 1. 2x to the 3rd, 2x squared, 2x. Negative 3 to the 3rd, negative 3 to the 2nd, negative 3. Now, with one thing you do want to pay attention to is when you have a variable and a coefficient that you're taking to a power, make sure you take it all to the 3rd power. So 2x to the 3rd power is saying 2x times 2x times 2x. So you should get 8x to the 3rd power here. Here I have 3 times 2x squared times negative 3. 2x squared is the same thing as 4x squared. 4 times 3 is 12. 12 times negative 3 is negative 36x squared. Here we've got negative 3 to the second power. That's 9. Positive 9. Positive 9 times 2 is 18. And then 18 times 3 is a positive 54. Just an x there. And then negative 3 to the third is negative 27. All right, that is all you need to know for Pascal's triangle.